Bart Brejcha. I work at a product development company called Design Engine, where we develop a wide variety of products for our customers, and we also run a school where we teach plastic part design with respect to SolidWorks or Creo or a surfacing class, for example. I invite you to explore our training classes. We also maintain a blog. We've ran a blog since 1994, and the word blog wasn't used until probably 2002. So let's see. Today I wanted to showcase the basics of Creo. We've done this when Creo 1 came out in a YouTube video. Now we're at Creo 12. We wanted to kind of showcase some of the basics of Creo to help people get started in using Creo. What I'm doing is I'm scrolling down to the Creo training class, the piston here. This is essentially a week-long course right here. We also have a wide variety of models to help people understand solid bodies and all the new things that get added to Creo over the years. So I'm going to click into the blocks index, scroll down, and just kind of show you some of the exercises. This is part of the first 2 days of training. What I want to do is think about how I'm going to approach block 16. I could start with an oval shape, or I could start with this keyhole shape, the letter T. I'm not sure if it makes sense which way I should start it until you try it and realize you don't like building it that way. I'm going to go ahead and think about how I'm going to approach it from an R&D perspective. Is you don't really care how it's manufactured. You're just going to 3D print it and let a manufacturing engineer worry about adding draft to the geometry. In this case, I have draft added to the geometry, and I'm using a draft check to see if everything's appropriated, and then I've added it to an assembly so I can move it around like a 3D printer chain might work. I'll make a handful of videos. So in this case, I think I could extrude the shape, or I could build the shape in its sketch form. I'll just pick one. If you can use visualization cues and think about how you're going to approach it and visualize the tools you're going to use, you might decide not to build it one way or another. I think that's really healthy. Does it really matter which datum plane you start with? But realize that if I sketch a shape on a top plane, that top plane will be my first view in a detail drawing. So that's how you figure out which datum plane you want to use. You don't necessarily have to square up on the sketch, but in this case I feel compelled to. I'm just going to draw the shape that I want to facilitate. Alright, so I hit the middle button when I'm done, and the geometry color's pink. So if I drag a sketch around, you start to understand that the equals aren't working for my strategic advantage. So I deleted the equals, hitting the delete key on the keyboard. So those are established sort of on the fly. We call it an assumption. So if you don't want this leg to equal that leg, you click the icon and hit delete. Most CAD packages are like that. So now I'm going to make this one line up to this one, the lines. I can use this tool to establish symmetry. Notice I didn't need to have a center line down the geometry. That's pretty helpful in terms of speed modeling. So I like to model things so they're not symmetrical. So when I see them get symmetrical, I know I've established the relationship I'm looking to establish. if this part has to couple this part in an assembly, why not dimension it to itself? That's a very design engine-esque move to do. Let's create a dimension from here to here, and let's start making some changes to the geometry. I wanted to make a change and see how it behaved. Maybe I want to dimension this geometry to the end. Now let's change it. Okay, so it's behaving the way I would expect it to. Okay, let's notice this coincident constraint here at the end. If I delete that constraint, I can change the geometry. So I tend to encourage young designers to think more in terms of making these planes relative to how the geometry is used in the assembly in some way. It's helpful. Not necessary all the time, but if somebody feels compelled to remodel your geometry, it's probably because the datum planes don't line up to anything. So now, what if I redefine this sketch and consider aligning the flat face to the datum? Maybe that's what's significant to my design. So at Design Engine, it's not how fast you model something that sets you up to be the expert. It's how fast you can change it 20 times. So instead of coming over here to grab this extrude, I can right hold down and hit extrude. Maybe that's faster. All right, so there's my geometry. Let's make a handful of changes to it. That's what I mean. I want to be able to make changes to my geometry. I know that this part has to couple this one when it's put together, so I might want to be able to make those changes in a rapid way. Now, in a later video, I'm going to put draft on this thing, make it a manufactured part. That's going to be a bit of a challenge if this is a full round. Let me put a full round on here so you can see what I mean. I picked both edges holding the control key down. I hit the round tool. I right hold down and grab the full round geometry. I can't add draft to that. If there's texture on the part, you would see a scrape mark coming out of the mold. Maybe we could consider adding a round to the top, hold the control key to the bottom. Now if I go to insert mode and add draft to this round won't fail. Let's do that real quick so you can see where I'm going with it. I'll go into insert, add draft to this wall. I'll make this my pivot plane. Now I can drag the yellow dot around to get a dynamic preview. SolidWorks is just starting to do these dynamic previews. 20 years late. And let's do a split draft at the draft hinge. Yep, and you can make those both go dependently if you want, so you only have to drag one or the other. Now, anticipate that this round is going to fail, but look, it doesn't. I'm going to delete the draft in the round and do it again. But this time, I'm going to put the draft on in a different order. How do I draft that wall? Put draft on there. Draft hinge. Look how the rounds just automatically get pushed around. That's the sort of new dynamic functionality that Creo added as it went from Wildfire 5 to Creo. Here, let's make it a split draft. Most of your senior level engineers wouldn't know this because they would just never think to put it in the wrong order like that. Draft sides dependently. Okay. So I don't plan on putting draft on this geometry. That's another video, but now I do need to finish my rounds. I'm holding the control key to make one round do all of that. Right, so let's see, I extruded this geometry. If I right click on this sketch, look how it finds all those edges. You can round all those edges if you want to. I'm going to delete that and not do it that way, but kind of an interesting way rounds work. That was new in actually Wildfire 2 20-something years ago. Let's add a round to just one edge. And I'm going to hold the control key down to fetch all those other edges. You can make it as big or as small as you want. The dynamic preview is pretty nice. You don't know what you want till you see it, then you want to kind of build those rounds kind of quickly. Now I'm going to build another round on this edge, and my intention is to snake it all the way around. And if you make this round too big, watch how this geometry turns into a triangle. Yeah, I don't like the triangle because if you try to solve FEA underneath that, it's going to fail. Won't triangulate properly, or at least that's how it's always been in the past. Notice how I forgot to put one round here? You could just add one or redefine the other round and hold the control key down to pick the one you forgot. And look, they're all documented here in these references. That you want to be mindful of those references, because when things start to fail in your geometry, it's usually that simple. All right, so there's my basic shape. I'll go ahead and put some some holes in my geometry. I'm going to use this as a hole tool and put a hole through the edge. Now I won't be able to align the hole perfectly to be coincident to those two rounds because it's not a full round, but I'll put the round in just the right spot. Now the cool part about the hole tool is in this case, it's asking for an X and a Y. What I'd like to do is put it with an axis. So what you would do in another CAD package is you would offset a datum plane here where you want the hole, and then you would hold both of those with a control key and add an axis. In Creo, we don't have to do that. We can take the sketch. You know, in this case, it's not going to work for me, but any place I add a point and extrude it, it's going to add an axis to the geometry. You just have to unhide it. Now I'm starting to think, each one of these points here is going to be mature into being an axis. You see that? Now if I would have extruded the oval shape, I would be able to do that. In this case, I don't have that luxury. So I'm starting to maybe wish I would have built it the other way, which is what we do for the rest of our lives as we explore an approach to build a geometry. It seems to be that as the problem. So let's do that. Let's offset a datum here. Dynamic preview of the datum. Hold the control key down to pick both of those geometries, and I can establish an axis at the intersection of those two. That's nice. We'll do that a couple different ways to get you some of the basics of Creo. Now let's grab this and the axis and reach for the hole tool. And notice I'm modeling this as if it were millimeters, and I'm in fact in inches. So the whole diameter is suggested initially to be rather small. So there's my hole, and I can dynamically change it to get the size that I want. Right now, I don't have an axis over here. I'm going to go ahead and establish one the same way. I'll offset a datum. Middle click, hold the control key down to pick two other datums. Look, I can establish an axis without coming up to this axis tool. This is a really cool function in Creo. You can Control C and Control V the hole. And now when I change this datum plane, the hole is going to go exactly where the axis is located. Control C, Control V is not new in Pro Engineer, but it was new to me in 1997. What's new is using Control C, Control V. That was new in Wildfire 1 in 2002 or so. Now I'm going to delete this datum plane and this datum plane. And notice when you hit delete, it deletes everything that's tied to it. How else can I put in a hole? Well, at Design Engine, we like to teach people to use surfaces as tools. So I could square up on this geometry and literally sketch a circle and literally extrude a hole. And now you've got a parametric geometry. The strategic advantage of that is it's less features and it's really quick. Here, let's just do it real quick so you can see it. As we discuss the basics of Creo, I'll just extrude it as a cut and right hold down here to say through all both ways. And that's another way to establish the holes. I like to use the hole tool because the hole tool can be redefined to have threads if necessary, which is super handy. Or you might want a clearance hole relative to another threaded hole. All right, I'm going to redefine that extrude and then remove the remove material portion and extrude it as a surface. Remember, I had right hold down on this dot and told it to go through both sides, or symmetric, and through all both sides. So when I converted it to a surface, it was smart enough to make it back to variable. That's pretty cool. Let's put it back to symmetric and make the whole, make the surface extrude smaller. So I'm going to use this surface extrude to establish an axis. You see it right there? There's already one. So let's see. Pre-select the axis, pick the face that I want to put the hole on, pick the hole. It's small because it thinks I'm in millimeter inches here. Right hold down on the dot and say through all. So there's my hole. And it's tied relative to this geometry. So if I move it around, it's of course going to go with. So surfaces can be utilized as a tool. It might confuse some people, but in class we want to show a wide variety of techniques so nothing confuses us. All right, so now I've got a sketch, an extrude, and a hole. I can go Control C and I'll pick the sketch where the sketch was placed and hit Control V, and it established, it looks like it put the hole back over here, but it put the new axis over there. Let's see if that's in fact what happened. Yeah, I can edit references on this hole and tell it to look at the other axis. Middle click. So that edit references is a pretty cool trick. I'll just delete the new hole and try to copy the old hole. Control C. What was it? You pick a face, you pick an axis, and Control V, and it knows to populate those two things. So copy and paste can be extraordinarily helpful speed-wise for some of our advanced part modeling classes, our speed-oriented workshops. All right, so in a subsequent video, I'll build an assembly. I'll add draft to the part, so it's a die-cast aluminum or forging. Thanks for watching, and consider taking a coffee or a tea and exploring the Design Engine website. And thank you for your time.